Okay, we are going to start the next unit by finishing off chapter 3. We're going to look at proportions and similar figures. We ended before our last test doing proportions, where we had to cross multiply. This lesson we're going to do the exact same thing, only this time we're going to have word problems, or basically we're applying what we learned in our last our last section of unit 2. We're going to apply it now. Okay, first vocabulary term to look at is called similar figures. Similar figures are figures that have the same shape but not necessarily the same size. So another way to look at it, they are proportional. Okay, similar figures are proportional. So what that means is we can set up proportions to use that to find missing sides of triangles or any shape that's a similar figure. In our first example, though, we're going to look at triangles. This right here, it says triangle ABC. This little tilde right here, I had it up here in your definition of similar figures, but that just means that these triangles are similar so that we know that our sides are proportional. So triangle ABC is similar to triangle DEF. And they tell them in that order. So A corresponds to D. So A and D, okay, and then B and C, B and E, and C and F, they're written in the same order. And we need to find AB. So we need to find AB. We don't know what that is. We're going to call, wait, it says to find AB. I'm sorry, I'm just realizing that there is an error. What I meant to say is we're going to find DE. So change that to DE. I apologize for that. Change that to DE. We want to find DE. We already have AB. That would have been a really easy problem. Find AB. Okay, it's 27, but that's not actually what it is. We want to find DE. So I'm going to make that a variable because I don't know what that is yet. I'm going to find out. So DE is an X. So now we're going to set up a proportion. Now there are many different ways to do this. But the one I'm going to go ahead and do is I'm going to start with this side CB as 32. I'm going to write it down, 32. And then I'm going to put it over the same length on the corresponding side. The side that corresponds to CB is FE here. Those two correspond to each other. So I started with this triangle with 32 on top, and then I'm going to put this one on the denominator over 24. So 32 over 24. So this is the triangle on the left, this is the triangle on the right. So when I'm setting up my proportion, this is where the biggest errors occur with these types of problems. The 32 is on this triangle here. So this is my numerator, okay? And again, there's more than one way to set these up. This one I used as my denominator. You just need to have them, I can't spell, I'm sorry, I apologize for that. Okay, so we need to keep them in the same order. So 27 corresponds to the missing X. These two sides correspond to each other. But this triangle we're putting in the numerator. So it's 27 over X. And then we're going to cross multiply. Okay, so we want to cross multiply. We want to take 32 times X. So we get 32X equals, and then we have 24 times 27 equals 648. And then we solve just like an equation. Divide both sides by 32. We get that X equals 20.25 centimeters. You always want to label when we know what dimensions we're talking about. Now I realize these triangles are not drawn to scale, because this says it's 24 and it's longer than what CB is. So don't go off of looks. That was just an inaccurate drawing. Their answer is 20.25 centimeters. All right, example 2. On these, okay, we got a shadow. You guys have probably done these before. A flagpole cast a shadow of 102 feet long. So what we're going to do is we're going to draw a flagpole. Here's our flag, okay? It casts a shadow that's 102 feet long. So here's this flag's shadow, okay? It's 102 feet long. Okay, and then we also have a 6-foot tall guy. Okay, I'm a stick figure person. I cannot draw, really. But we have a 6-foot tall guy. Okay, and he casts a 17-foot long shadow. All right, so what we do is we create right triangles because we got the vertical and the horizontal. They create a right triangle. Okay, so they create a triangle here where they're similar because when the sun shines down, it's going to create similar figures here. So we want to know how tall is the flagpole. There's our X. All right, so again, we have to set up these. I'm just going to say this will be in my numerator. It might help if you label these like that, and this is my denominator. Okay, numerator, denominator. So my numerator, I'm going to put X over. The corresponding side for the denominator is 6. Come back over to the numerator, and I get 102 over 17. Okay, and again, there's more than one way to set it up. I think this way it just kind of helps keep things track. You could also have done X over 102 equals 6 over 17. That would work as well. Cross multiply, we get 17x equals, all right, 102 times 6. $612, and then we divide that by 17, and we get 36. So we get x equals 36. So our flagpole is 36 feet tall. Okay, our flagpole is 36 feet tall. So on these, it's good if you go ahead and draw a picture. Okay, let's go on to example 3. All right, there's a map here. The scale of this map is 1 inch for every 10 miles. The map distance, okay, here's a mistake. I remember this mistake from last year, and I failed to correct it. This should not say Aurora. That should say Monette. Aurora is not even on this map. So the map distance from Monette to Marionville is 2.375 inches. How far is the actual distance? Okay, they give us a scale. The scale is 1 inch for every 10 miles. We can set up proportions, use that to find out what the distance was from Monette to Marionville. Now, the numerator, again, I'm going to label this. The numerator is your map distance, okay? And the denominator is your actual distance, all right? So on the other fraction, then, our numerator needs to be our map distance. Well, they told us our map distance is 2.375 over the actual distance. That's what we want to know. We want to know the distance from Monette to Marionville. So when we cross multiply, we get 1x, which is just x, equals, and then 10 times 2.375 is just going to be 23.75 miles. All right, so that's how you can use maps that use the scales if you have a scale. This can also be done if you have a scale model of something built. These proportions will work for that too. All right, let's go ahead and look at example 4. Okay, example 4, we have quadrilateral PQRS. They give us the vertices. P is -2, 4. So I'm going to go ahead and put these on my graph, and I'm going to label them. P is -2, 4. Remember, you go left or right first. So we go -2, and then we're going to come up to 4 and put a point. So this right here is P. Q is 4, 4. So go over 4, up 4. That's Q. And then R is 4, -2. 4, -2. So that's R. S is -4, -4. Okay, so that's where S is. So then I'm going to connect these dots. This is the kind of figure that we get. It's kind of like a kite. All right. Now, we're going to talk about dilations. Dilation, if you think about it, like when the doctor looks at your eyes, he talks about how they dilate. That's when your circle gets bigger and smaller, your pupil gets bigger and smaller. It's still a circle, it has the same shape, but it changes size. So what that means is that, when when the eye starts out and then it dilates, you have a new circle, but they're still similar to each other. That circle does not change, it just changes size. So when we do a dilation, the two figures end up being similar. So we want to dilate this by a factor of 1/2. Here's how you go about doing that. You take each of the points. We'll start with P is -2, 4. We multiply this point by 1/2. So what that means is you multiply each of the coordinate points by 1/2. Okay, so you get the new point, which we call P prime. Okay, this is just what we call, this point corresponds to this. This is the new point dilation. We just put a little 1 up there. That's called P prime. So our new point then is we have 1/2 of -2. 1/2 of -2 is -1. 1/2 of 4 is 2. So our new P is at -1, 2. Right? And we do that with the same thing with each of the other points. We multiply them each by 1/2. So our new Q, which is Q, and then remember we put a little thing up here to say that it's Q prime. That's just a notation, guys. Don't let that get confusing. 1/2 of 4 is 2. 1/2 of 4 is 2. So our new point then for Q is 2, 2. Then we have R. R is 4, -2. Multiply that by 1/2. Our new point is 1/2 of 4, which is 2. 1/2 of -2 is -1. All right? Then we got one more point to do. We want to multiply the point -4 by 1/2. So our new point, S prime, we end up with 1/2 of -4 is -2. So we get -2, -2 on that one. Now we plot our new points. P is -1, 2. There's our new point. 2, 2. Then we have 2, -1. And then we have -2, -2. And as you can see, it's the same shape. Okay, it is the same shape. It's still kite. It looks like a kite. I think I'm pretty sure it's kite. So it's the same shape, but it's just not the same size. It's kind of been halved. So this is called a dilation. Dilation can either go smaller or bigger. But either way, these figures would be proportional. Okay, so that's how we use proportions. This is how we apply it to other types of problems. Thank you for watching.